The Internet of Things, or IoT, is comprised of millions of devices connected via the Internet to corporate databases and applications. These devices include small sensors and other low-power devices that execute simple functions such as collecting data. While simple, they are crucial to enabling smart cities, smart agriculture, smart homes, and smart utilities. Designed to be cheap and consuming low power, these sensors are, at times, not capable of implementing security measures used on other devices that are more powerful. Nonetheless, the risk of malicious attacks exists. Hackers target these vulnerable devices in order to attack higher value assets. TrustZone for ARMv8-M is a new security architecture from ARM. Designed for devices implementing their new v8M microcontroller architecture, TrustZone for ARMv8-M brings greater security to devices that are based on ARM Cortex-0, Cortex-0 Plus, Cortex-M3, M4, and M7 architectures. TrustZone for ARMv8-M provides a framework for designating secure memory regions. This effectively creates secure and non-secure domains. This allows for the isolation of functions and data that are critical to securing the device into the secure domain and out of reach of untrusted software. CoreLockr-TZ is a lightweight software dispatch layer that eases developers' access to TrustZone for ARMv8-M. It does so by abstracting complex aspects of the new architecture, simplifying application development. To use TrustZone for ARMv8-M, application developers must modify their application designs. Functions critical to security must be separated from the main application and rewritten to execute in secure memory. Application functions in non-secure memory must follow new procedures to access resources and functions in secure memory. This takes training, which adds cost and time to market for products using this new and useful technology. Imagine the cost of training every developer on the new architecture. The reality is that not all application developers need to understand the new architecture at such a deep level. In this demo, we have a TrustZone for v8M enabled device with CoreLockr-TZ implemented. The board in this demo emulates a small, low-power microcontroller-based device. The demo shows how such devices can be secured using TrustZone for v8M and how developing the application is simplified using CoreLockr-TZ. Let's first go over the security capabilities of TrustZone for ARMv8-M. Remember that with TrustZone for v8M implemented, the device has two types of memory regions, secure and non-secure. Secure code runs in secure memory. Let's call that the secure world. Non-secure code runs in non-secure memory, or the normal world. The demo shows two types of vulnerabilities. One, where code running in the normal world stops working, and two, when malware tries to access the secure world. In both cases, we show how code running in the secure world keeps running and takes remedial action to protect the device by restarting the normal world. In the demo, you see two LCD displays. The LCD on the left is connected to the non-secure or normal world, while the other LCD is connected to the secure world. The counters on each LCD are proof that each world is active. The two large buttons are used to invoke each of the vulnerabilities we described earlier. Let's begin. The secure world contains a watchdog function that monitors the normal world. If the watchdog function is not stroked periodically, it registers as a fault in the normal world. Pressing the yellow button causes the normal world to miss a scheduled stroke with the watchdog function. Upon detection, the watchdog momentarily turns the secure world LCD screen red. The program then remediates the situation by restarting the normal world. Note that in this operation, the counter connected to the secure world continues counting, proof that the secure world never stopped working, even though the normal world did. This means that TrustZone for v8M increases the reliability and uptime of critical processes when executed in the secure world. The normal world reset is evident when its associated counter resets to 0. In the new TrustZone architecture, applications or malware in the normal world cannot access any part of secure memory in the secure world. Doing so causes a fault in the system. Pressing the red button causes the fault in the system and the secure world LCD momentarily turns red. Remediation occurs through the reset of the normal world. This demonstrates how a device is protected from malware and addresses customers' concerns with regard to protecting intellectual property, keeping critical processes running, and protecting sensitive data from hackers. CoreLockr-TZ helps simplify access and use of TrustZone for v8M. In this example, CoreLockr-TZ is installed in the secure world. However, its location in secure memory is unknown to non-secure applications. It is only accessible through its veneer that resides in another memory region known as non-secure callable, or NSC. Secure code developers can register secure functions as services with CoreLockr-TZ's service registry. Non-secure code developers desiring access to these secure functions need only to call the CoreLockr-TZ veneer in NSC memory. The veneer calls on CoreLockr-TZ in secure memory, which directs the request to the appropriate secure function. In effect, CoreLockr-TZ acts as a distributor for all secure functions that are held in secure memory. TrustZone for ARMv8-M brings foundational security to small, low-powered devices and takes us closer to achieving end-to-end security.